Inna Ziber. I am the second lecturer on this course, and today I'm in charge. During the first class today, I will speak about supersegmental features and supersegmental parameters. And the second class will be devoted to reading the spectra. We'll put together everything you already know, and we'll have some practice. First of all, I'll give you some links. I have just sent them to the chat. Do you see my links? Is it okay? Do you see my links? When the time comes, I'll ask you to follow the link and to watch the video to the point that is noted in this text in the chat. So I'll move on to my slides, and links are now your responsibility. Do you see my slides? Please say yes.
Yes.
Yes. Okay, perfect. Supersegmentals. This word contains Latin prefix supra, which means beyond. So supersegmental features and supersegmental units and parameters are those that are beyond segments. We can speak about prosodic. Prosody is more or less the same as supersegmental. Phonetics or supersegmentals are prosodic units and prosodic features. When we speak about supersegmental level of the phonetic system, we see at least three very important differences. We see differences in at least three very important aspects that we see them in comparison to the segmental level of the phonetic system. First one is hierarchy. When we discussed segments, vowels, and consonants, we saw them as more or less equal to each other. I mean that they are more or less comparable in terms of duration and features. Some people even find same features for vowels and consonants. We just made combinations and sequences of the segments, and they are more or less equal to each other. When we have supersegmentals here, they form a hierarchy. We can, of course, any sequence of any speech consists of some segments, but beyond this, we have syllables that form words, that form prosodic phrases, that can form an utterance, and this is a hierarchy that we notice in different aspects of discussing prosody. The second thing is structure. When we discussed segments, we just had some features and features that in combination helped us to produce a sound or to perceive a sound. But here in supersegmentals, they have some linear structure. In a syllable or in a word, in a prosodic phrase, in an utterance, we have a nucleus, which is the center, the most prominent thing in this unit. We have periphery and we have boundaries. And this type of structure is the same in different prosodic units, in moras, in syllables, in words, in prosodic phrases, and in an utterance. The next important thing is that in these units, demonstrate this link to the hierarchy when they are when they can be analyzed. I mean that in a syllable, the nucleus is what is a nucleus in a syllable? What is a nucleus?
A vowel?
Vowels, yes, vowels, or at least some syllabic consonants are nuclei in a syllable. In a word, what is a nucleus in a word? Any ideas?
A stressed syllable, probably.
Okay, stressed syllable. Stressed syllable is a nucleus in a word. Well, we have, when we go to the another step of our hierarchy, we have a nucleus in terms of this previous step. Well, in a word, a syllable, one syllable of others is a nucleus. When we come to the prosodic phrase, one word of the phrase is a nucleus, and when we come to an utterance, etc. We have a nucleus, we have periphery, and we have boundaries. This can be very important when we go from language to language, because each language marks this structure differently. We can have one syllable that is marked one or another way in different languages, and we can have periphery and boundaries marked as well. For example, do you know any examples of marking boundaries in a word or in a syllable? Any examples of how the beginning or the end of the word of a syllable can be marked in a language? In any language.
Do you mean devoicing? Or like that?
Devoicing? In what position?
In the end of the word or morpheme. It depends on how we treat it.
Okay, in Russian we have final
Yes.
devoicing. Okay, in Russian we have final devoicing. In German we have devoicing in the end of the syllable, if I'm not mistaken. Am I? Final devoicing, but devoicing can mark the end of the word, like in Russian, or the end of the word and the end of the syllable, as it is in German. Well, this is this right boundary that is marked in a language. And we can mark the end of the syllable, the end of the word, the end of the prosodic phrase, using intonation as well, as somebody noticed, just noticed in the chat.
May I? It's not true that in Russian, it's not true that at the end of the word we have voiceless consonants.
I don't think that we put it this way. We say that we have some marking this boundary of the end of the end of the word. We have final devoicing, but this final devoicing can be influenced. This devoiced consonants can be influenced by this by the right context, but it does not mean that we don't have this this final devoicing. And we see this final devoicing when there is not such an influence before vowels and when before pausing. So we see this boundary, but sometimes it is like there is something more strong than this boundary, and one process is more strong than another. Well, periphery is important because it is in contrast with the nucleus. So in every prosodic unit, we have a nucleus, which is in contrast to the periphery, and we have boundaries that can be marked or can be not marked in different languages and in different positions, even in the same language. The third thing that is important to notice is structure of, I can't even say inventories. When we discussed segments, we spoke about inventories, segmental inventories, vowels, consonants. They are just lists of segments, and when a language chooses this inventory, builds up this inventory, this language can just take one segment or another and make utterances out of this list, out of the segments of this list. And when we have supersegmentals, we don't have inventories, but we have schemes. Take any language, we can't make a list of all possible syllables. Well, we can do this, but it is more or less it makes no sense because what is possible or what is impossible for this language in terms of syllables is more conveniently explained in terms of schemes. So we have some schemes, we have some rules of building these supersegmental units out of segments with these segments. So we have schemes of moras, syllables, phonetic words, prosodic phrases, some schemes and rules of how they can be built. These three important things differ prosodic level from segmental level. What terms are important to us here? There are units. We already mentioned them. Moras, syllables, words, prosodic phrases, and utterances. And maybe, are they familiar to you? Do we have to discuss any of them that can be interesting? Well, we have some.
The first one.
Sorry?
Can we discuss the first term more?
Okay. We all have syllables in all languages. We have syllables more or less defined, more or less understandable, more or less okay. More or less understandable syllables, but moras, we find moras not in all languages, but in some languages that look at the syllable as not as at some simple thing, but as a complex thing. For example, if you know Latin, in Latin we have syllables of different types. We can have a short syllable that consists of a consonant and a vowel, CV, and we can have a long syllable. Long syllable which consists of that can be CVC, or it can be a consonant and a diphthong, and it can be a consonant and some long vowel. So we have some, we have the smallest of possible variants, which is a mora, and we can like split, but not split, but we can prolongate this this unit by adding something. We can add another vowel, or we can add a consonant or make this vowel longer, and then this unit is it is still a syllable, but it consists not of one mora, but of two moras. In some languages, we'll speak about it later, but in some languages, we can just predict the length of all utterance using the number of syllables. For example, in French, if we know the length of one syllable, the duration of one syllable, and we have a number of syllables, we can know the duration of all utterance. And in other languages, for example, in Japanese, we just can't multiply and using the number of syllables, because syllables can be very different in their duration, and it depends on how many moras they have. One mora syllable is shorter than two mora syllable, and we can in those languages we can predict the duration of the whole utterance using moras, not syllables. So mora is a part of a syllable, which is the smallest possible supersegmental unit of some languages. Well, in Russian or in English or any Romance languages, moras are not important. They don't exist in perception, and well, we can describe languages without moras, but for some languages, moras are very important, and there is no language without moras. Well, units. Features, when we spoke about segmental features, they were like place of articulation or manner of articulation. It could be some complex articulations or additional articulations, and in the prosodic level, features are stress, or lexical tones, or intonation, or rhyme, or tempo, and they can be applied to different units and different situations. And in reality, these features can be described in acoustic parameters like pitch, intensity, duration, and sometimes phonation and quality, which depends on the language and depends on the feature. So we'll look at some features and discuss parameters that are important for these features in different languages. We'll concentrate on word stress, lexical tones, and intonation as these topics are the most important. We'll focus on types of these things and descriptions, and more or less a little bit of typology, and we'll discuss how to measure them using Pratt, using our instrumental techniques. First thing is word stress. When we just say stress or accent, we can mean at least two different things. One thing is word stress, and another thing is prosodic stress. Prosodic stress, or another term is phrase accent or phrasal accent. It makes one word in a phrase prominent, and word stress is a thing that makes one syllable of the word prominent. It is always one in the and the background is other words, other syllables, and the background is this periphery of the prosodic unit. In a word stress, there is a question whether its domain is a vowel or a syllable, or maybe the whole word. And it seems to me that it can differ from language to language. And which is important, there is another term, lexical stress, and it's not the same as word stress. Lexical stress is a word stress that can distinguish between words and word forms in a language. So every language, or almost every language, has word stress. Not every language, but all, many languages have word stress, and lexical stress is not so widespread. When we speak about word stress, we try to find out what parameter is important to make one syllable prominent. What parameter is different in this very syllable in comparison to others. So these parameters, acoustic or perceptive parameters, can be as follows. It can be loudness or intensity. It can be duration. It can be pitch or fundamental frequency, acoustically, and it can be vowel quality or reduction. Reduction is not a reduction is not a feature that characterizes stressed syllables, but it characterizes another syllable. It is a characteristic of periphery of this prosodic unit of a word. Another thing is that it is always it is a very rare thing when only one parameter is responsible for stress in a language. It is normal for a language to use several parameters in the same time. And one of them seems to be the most important, and we can speak about types of word stress depending on what parameter is the most important. Let's look at this at the picture. It's a very nice word, tarakane or tarakana, which is a cockroach in Russian Allegro speech. And here we have one syllable that is prominent, one syllable that that differs from others perceptively, and it is the third syllable ka. And I mark it with a stress here. And let's just look at this spectrum and discuss what parameters make this syllable, this vowel different from others. Parameters. It was loudness or intensity, but we can't see intensity here very well, but we can measure just using your eyes. You can measure duration and maybe vowel quality. What about duration? Let's just speculate.
So schwa is obviously shorter than a. I don't know, I think in it's 2 times shorter at least.
It is, yes, it is. Schwa is shorter. What else can we see when you say schwa? We also see that the phonemic transcription that I have in the top of the slide uses a 3 times, tarakane. And here in the spectrogram, I use schwas, schwa here and schwa here, and a 2 times here. So I already show this quality, this difference in quality. But this difference in quality, as I show it, it is not a difference in quality between one syllable and others. What is it then? Where we have this short schwas and where we have long R.
You have a long R in the middle of a word, in the middle syllable, and the shorter schwas at the beginning and in the end.
Yeah, we seem to have a normal stressed vowel R, which is here, and we also have a pre-stressed normal R, and everything which is not stressed or pre-stressed is under reduction. We have reduction here, we have reduction here, and it is a quality of a vowel and a quantity duration of vowels. So we see here that what we can see is that some syllables are marked as peripheral, as a part of periphery of this word, and these two syllables seem to be more or less the same. What is this spectral difference between these two R sounds? Is there any spectral difference? Any ideas?
Sorry, between which two sounds?
Two R sounds.
It's probably the formants are different. The second and third formants.
Maybe they're not so different. Here is this fundamental frequency, and somewhere here we have this first formant, and somewhere here we have second formant. So they are just merged into one I don't know, porridge. And here we have the same formants, but the second one is more pale. We have more bright ones here. Do you see this? These are darker than here. So the darker, the more intensive. So this pre-stressed R is louder than the stressed one. So we know that this one is under stress, as I'm Russian, it's my language. I know that it's a stressed syllable, but this one is prominent in terms of intensity, and these two are prominent in terms of duration. And which one is really stressed? How I can explain that the second one is stressed? Well, let's look at the intensity. Intensity. This line shows us intensity changing. The higher, the more intensive. And here we see this zero intensity in closure, in a voiceless closure of K. And here we have peaks of here we have peaks of intensity, and we see here that in these pictures as well, we can see that the pre-stressed syllable and even this one, schwa, are more intensive than this stressed syllable. It is strange, and we can also check what is going on with the fundamental frequency. And here is the pitch of this utterance, Drakana. Here it is. Here we can't see anything here. How is it possible? Why is it so?
Because it's voiceless.
Yeah, we have a voiceless element here. We have a voiceless closure and voiceless noise. So there is no fundamental frequency here, but we have a fundamental frequency here, and it's very difficult to choose one of these syllables because one of them is prominent in pitch. In reality, we just can't. When we see the spectrum, we just can't choose one syllable that is prominent in Russian, but we can choose two, and two syllables, the stressed one and the pre-stressed one, are really longer and more intensive than other syllables. And this complex of two syllables in Russian is called the prosodic nucleus. So the nucleus in this word is not one syllable. In Russian, word is not just one syllable, but two syllables that are different in quality, in freedom in quality, freedom for vowels, but in intensity and in pitch and in quality, more or less, and in duration, the stressed one and the pre-stressed one are more or less equal. So it is a rare situation. So it's there are, I don't know, languages that have this kind of stress when we don't have one syllable, but we have two syllables at the same time that are prominent. But this is what can happen. Well, when we have when we want to understand what is the most important feature that differentiates between stressed syllable and other syllables, we go on from duration to quality to intensity to pitch, and we measure every feature and try to find anything that is that makes this stressed syllable prominent. So let's move on to lexical tones, as it is really very important and very interesting topic. Pitch and tone. We have three basic terms that are used when we speak about prosody or tone or anything. And it is fundamental frequency, this zero formant. It is an acoustic term. We have pitch, that is a perceptual concept, or it is the same as fundamental frequency, but we use it in perceptual contexts when we are not interested in acoustics, but in what we hear. And we have tone, which is a phonological term, a linguistic term, and it is not always consistent with pitch or fundamental frequency. So we should differentiate between these things. And when fundamental frequency and pitch are more or less the same, tone can be absolutely different. Well, what supersegmentals use pitch? We have intonation and we have tone, and they both use supersegmentals, but they both use pitch in making anything prominent or in organizing themselves. The domain of intonation is prosodic phrase or an utterance, and for tone, the domain is a syllable. In intonation, pitch is used along with the pause or phonation and duration of vowels and even consonants. And in lexical tones, pitch is more or less independent. It can be used with other parameters, but in tones, pitch is the main thing. And intonation helps us to distinguish between different types of information structure, between different purposes of speaking, and tones use pitch to distinguish between words and word forms. Tones or lexical tones are changes in pitch that can distinguish between morphemes and words and word forms. They are independent from phonetic position, as phonetic position can influence pitch, and for example, voiced and voiceless consonants of different places of articulation make pitch be different, make pitch change a little bit. And lexical tones are independent from phonetic position. Lexical tones can characterize each syllable of the word, and they can combine pitch with phonation, intensity, and duration as well. In lexical tone languages, tone is distinctive, and it is an essential feature of morphemes, words, and word forms. Here is the map from the World Atlas of language structures, and here we can see that we have no tones in what? A little more than a half of languages have no tones, and others have tones. But there are different scholars have different opinions of how many languages have tones, have lexical tones, and how many languages don't. Some authors say that we have tones in 70% of all world's languages. But when we see this map, we can notice two places in the world where most of these tone languages are concentrated, and these are this one and this one in Africa. Americas, well, we have all possible things in America, so it's not diagnostical. Typology in typology we can find two types of tones. The first type is level tones. Level tones differ in pitch, and they have different pitch, but it is more or less the same. So we have extra high or mid and low, extra low, and they are marked with capital letters, consistent to the terms. Another type of tones is contour tones. They differ in direction of movement. They can be of different level, but the main differences between contour tones is the direction of this movement. Simple tones are rising and falling, and they can be also complex, rising, falling, or falling, rising, and we can combine this level or register and contour in one tone. For example, a tone can be low rising or high falling, etc. But the basic typology is the same: the level tones and contour tones.
Excuse me.
Yes.
Can I ask a question?
Of
On the two slides before this one, I mean,
Yes, with the map. Yes, we have seen the distinction between simple and complex tone systems. Is it the same distinction as with level and contour? Is it connected to this opposition of level and contour tones?
Well, in this picture, we don't have languages. We just have tones. So it is not the typology of languages, but just the typology of tones that can characterize syllables in different languages. So this slide can't answer your question, but I think that in several slides we'll go on to this.
Okay.
Mm-hmm. So don't forget, please. If I forget, remind me. In this picture, we have thigh level and contour tones. So we have both types of tones in one language. In thigh, we have mid and low and high contour level tones, and we have falling and rising contour tones. So this picture is a little bit confusing. So I've just said that level tones are like plane and contour tones are movements, but we see all of them moving here. Maybe this mid-tone is more or less calm, but others are constantly changing. So when we speak of level tones, they are not really they're not really they're not really faithful to their levels, but level tones are linked to their level, and in contour tones the direction is the main thing, not level but direction. This was a typology of tones, but tone systems, but the typology of tone systems seems a little bit different and a little more complex. In languages, in tone systems, we have two types of those. We have register tone languages and contour tone languages. In register tone languages, we have level tones only, and in contour tone languages, we have both level tones and contour tones. So there are no languages that have contour tones without level tones. At the same time, there are languages with only this level type of tones. So if just to count how many tones, how many different tones we have in a language, we will find out that register tone languages have less tones than contour tone languages. So in that map, simple tone systems were more or less consistent to register tone languages, and complex tone systems were more or less consistent to contour tone languages. But it is not so simple, and I refer to the chapter in World Atlas of Language Structures, and Ian Madison explains the method and the meaning of this map more precisely. Let's move on to register tone languages. In register tone languages, word is a sequence of level tones. So there can be several syllables, or even many syllables, and each syllable has its own tone. In Yoruba, we have 3 words that are segmentally equal, but the second syllable differs in tone. It's high in he met, it's mid in he hided, and it's low in set. And it is important for the differences in semantic differences. In register tone languages, there can be contour tones as well, but they're predictable. They're predictable, and they are always explained by phonological rules. Please look at this example. We have here ke urua, which is high and low, 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 and then they are they make up one word, and we have two vowels that are that merge in one, and two tones, high and low, that characterize these two vowels. They merge as well, and we have falling from high to low. We have falling and low, low. So there is a phonological rule: when we merge two vowels, we combine these two level tones, and we have a contour tone, which is predictable. So register tone languages can have their own contour tones as well.
Sorry.
Yep.
And the fact that we originally had this high, low, 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 it's only because, why is it so? I mean,
it is a lexical characteristic. So you just open a dictionary and there is this tone or that tone. It is as it is the same thing as a choice of a segment. Why we have ko here? We just have, there is an historic explanation. They can be borrowed, etc. But as we have this this sequence of segments, in the same time we have this sequence of tones that is consistent to every syllable in this word. So it's just another feature that is linked to syllables, not to vowels or consonants, but to syllables. So
okay,
it's
I just sorry, I just mean that it already appears to be a counter tone even before the duration, or it's not, or I got it wrongly.
You mean this ethic example?
Yes.
Well, we can, in any language, let's just take a segmental example. We can have two words that contain some segment, and we know that it is there. And when this word or this segment comes to another position, we can see it changing under the influence of this position, and you can change the context and just see how this segment changes in different positions and without any influence at all. So the same thing is in tones. You can combine different words and see that in one position it is this tone, and with no influence it is okay, with a level tone, and when you combine them in such a way, you see that
Yes, yes.
they're changing. So I don't know ethic, but Kurwa is at the market, and maybe this at the market is either a prefix or some case marking. I don't know, but this is something that you can take away from this word form. And this and here I ask you to play the Yoruba video in your chat. just follow the link, the Yoruba link in the chat, and please listen up to 2 minutes. Have you succeeded in listening to these Yoruba tones? Who is okay with Yoruba tones? Please raise your hand for me to know that you have listened. Okay, 3 of you. It's less than one minute. Okay, I'll be happy if you raise your hand. No, not clap your hands, because clapping is it vanishes in a minute. So raise your hand if you have listened to this Yoruba woman. Maybe 10 seconds. Okay, thank you. Well, you see that how many tones are there in Yoruba? How many tones? 3 tones, and they name them after notes, do, re, and mi, and because they are one is higher than another, and we have 3 of them in Yoruba, and it is shown in the diacritics in orthography. Well, in Guinea-Pele, we also have this register tone system, and I hope that you will be able to hear what I'm going to play. Please look at the orthography, look at the writing, and try to follow the sound. And please, if there is no sound, please tell me.
Nga belalema. Nga belalema. Nga belalema. Nga balalema. Nga balalema. Nga balalema.
So what's the difference between 2 examples? I see three hands, but I don't know whether it,
Yeah, I forgot to put it down.
I shall put, it's wrong hand. Who can tell me what's the difference between these two
The
examples?
second is a rising tone.
Hmm?
Rising tone is a rising tone.
In which one?
Second.
Second one is, let's listen. Yes, tones are different. Let's listen one more time, please. Please try to notice what is the exact place when we have another tone.
Nga belalema. Nga belalema. Nga belalema. Nga balalema. Nga balalema. Nga balalema.
We can just look at the pitch contour of these two pronunciations, and we see that in the second one we have this falling here, and there is no falling. There is no falling in the first one. Here we have consistent syllables. Well, we see that it is not the only thing that is different in these two words, and this "na" word that it is supposed to be the same in these two utterances. We see that it is not exactly the same because tones influence each other, and when we have high tone here, we have no. It is not necessary. It is not necessary to rise this tone in advance. And here we have this rising before falling.
Nga belalema. Nga balalema.
In level tone systems, we usually have only two tones or three tones. If we have two tones, they are low and high, like when we have two or three vowels, they begin with these polar positions in this triangle. So the tones tend to polarize, tend to choose the maximum of differentiation that is possible. So we have low and high, or low and high and mid-tone, and one of them is always basic. When we have three tones, so the mid one is usually basic. In level tone systems, we have this the sequences of syllables, each one and each one of them holds this syllable. And when we change words, when we add affixes or remove affixes, tones can change as well. Affixes can be neutral, or they can bear tones themselves. Tones can spread from root to affixes or from affixes to root. It depends on the language. And even one tone can spread over the word, and these rules are also depend on the language. We have a nice thing which is called downstep in tone tracing. It is a change in tone through time. When the utterance is going to its end, the airstream is decreases. We have less air to breathe out. We have less strength to breathe out, and so the fundamental frequency decreases as well from the beginning of the sentence to its end. And when you pronounce a sentence in a register tone language, you have this differentiation between high and low tone in the beginning of the sentence, and this difference decreases. This difference decreases to the end of the sentence as when you just begin the sentence, your high tone is really high and your low tone is not very low. And when the sentence is going to its end, your high tone is much lower than it was in the beginning of the sentence. And it is down step. And if you have three tones, for example, low and mid and then high, low and mid can merge in the end of the sentence. And then when the sentence is over, you just breathe in and you reset the system, and it is a new start of, and low and high and mid tones are they become themselves again. So it's down step. There are constraints on tone sequences, just the same way that we have constraints on segmental sequences in every language. Tones can change if some affix, for example, or prefix creates this prohibited tone sequence. If the tone sequence is not possible, is prohibited in the language, tones change in a predictable way. Well, let's move on to contour tone languages. We've already looked at thigh tones, and there were lots of them there. In contour tone languages, we have at least one level tone. It is necessary. And we also have contour tones that are not derived from this level tone, or level tones if there are lots of them. Contour tones are important in their direction of movement, and level tones are prominent in their register, in their level, in their pitch. And phonation, as we have lots of tones in contour tone languages, there can be 4 or 5 or 6 or 7 of them. You can also use additional features as phonation, or you can use a glottal stop as a part of this contour tone system. The typical example is Chinese, where we have 4 contour tones, where we have 1 level tone and 3 contour tones. And here I ask you to watch 2 videos. One of them is one link is named Tones Chinese, and the next one is Tones Vietnamese. Please watch these 2. Please watch these two videos, and we'll continue after. And let's continue after a short break. Will you be so nice to watch these videos in the break so that we could continue at 7:30? Is there any objections to watch several minutes in the break? Objections?
No.
You're very nice, thank you. Please watch these 2 videos, and let's just gather back at 7:30. Hi again. Are we ready to start now? Can you please put a plus in the chat so that I could know how many of you are here?
So I have a question about register tone languages and contour tone languages. So in the register tone languages, we just have fewer tones. So we just don't have this high and low pitch and etc. And in contour tone, we have it. So could you explain, please, once more time the difference?
Is everything okay with the sound? I have problems with it. It seems to me that it's only me who has problems. Excuse me, I need 1 minute. Can you please repeat your question about contour tones and level tones, or contour tone systems and register tone systems?
Okay, so I didn't grasp the difference between that, and I started looking in the internet and like, you know, Britannica.com, and it says like register tone languages uses tones that are level, idest, they have relatively steady state pitches, and, which differ with regard to being relatively higher and lower. So I don't know, steady state pitches. It means that it's like one neutral tone, but they're higher lower. So I don't get the difference. Is the difference between register tone languages and contour tone languages in the number of tones, or it is in something else? So maybe that is my question.
In register tone languages, we can have several tones. It's 2 or 3 in average, more or less always it's 2 or 3 tones, and all of them are level tones. So it's the left part of this chart. So all of them have more or less the same pitch in a syllable. So pitch is more or less the same when you pronounce this syllable, and this syllable can be high or can be low, or can be somewhere in the middle. So
okay,
you
so,
can have.
So maybe yes. So maybe that is that I don't understand what is like extra high, mid, low, extra low. So I understand what is like high voice, like falsetto, or low voice like bass. Yes. So, but what does it mean here, like level tones? And what is the difference between rising and falling? So is rising always high and falling low? But now it says it's low rising, high falling. So I just don't grasp the difference between these
Okay.
two.
When we speak about tones, we mean some feature that is connected to pitch, so to fundamental frequency. Fundamental frequency is what we hear as intonation when we hear someone speaking. So it's intonation, or we can imagine any musical instrument and take one note and then another, and they can be higher or lower. I don't know. Do is lower than Re, Re is lower than Mi, and etc. etc. We can control this pitch, we can control our fundamental frequency. Now I'm speaking in a higher tone and now I'm speaking in a lower. So we can control this parameter, and we can control it in a domain of every syllable. I can pronounce one syllable high and then one syllable low, and I can switch between these tones, between different tones, between different levels. So that we can just take some word and put it down in syllables, in letters, and at the same time in notes. Because pitch is different. Is it okay?
Yeah. So now I see. So if do is extra low, so Re is low, mid is Mi, high is like Fa, and extra high is Sol. Is it like this?
More or less, but not exactly. So
yeah. But I so like every speaker of the language, no matter which natural voice he or she has, should speak like in bass when they pronounce extra low sounds.
Absolute pitch frequencies can be different, and they are different because we all have different basic pitch, different fundamental frequency when we speak, because we all have different vocal folds. But it's about levels. The exact notes can be different, but when I speak in a three-tone language, I have these three levels. When you listen to this Yoruba woman, she tried to show you the three levels. They were named after notes, but they are not exactly on that pitch that any notes are. And this pitch can also change in an utterance, in a sentence. So in one language, we can have only two tones, and they be somewhere high and somewhere low. And in this particular person's speech, in this particular person will use these two levels as ideal high and low tones. But another person can use other frequencies of pitch for these two tones. And if we have some language with not two but three tones, this low can be lower or high can be higher to give this place to a mid-tone to differentiate between them. So we can't say that Do is extra low or something like that, because the absolute frequencies are different for different people. But this, what is important is this number of levels and their relationship. So how many levels you have, and the one that is low should be lower than the one that is mid, because it's a part of lexical information about this word.
Okay, yeah, I think that now I see more or less. Yes, thank you.
So the relative frequencies are more important than absolute ones. And in contour tones, the direction and the register is more important than just some pitch or level. And if you are now familiar with Chinese tones and Vietnamese tones, we can just go and look at them. We have 4 Chinese tones, and we can write them down as notes, and it's okay. But for us phoneticians, it's a little bit more appropriate to write them down as spectrograms. And here we see 4 syllables that are pronounced with 4 different tones: first, second, third, and fourth. And the blue line is, what is it? Blue line. Blue line is a fundamental frequency, and the scale for this fundamental frequency is on the right. So we have a scale here from 0 to 500 hertz. It's on the left. And on the right, we have another scale from 30 hertz to 300 hertz. Do you see this? The letters are in blue, and the lines are in blue as well. And these lines show us the different how pitch of the voice changes in 4 different syllables. And the first tone is level tone. It's high level tone. The second one is rising, and it's high rising. The third tone is a complex one. It falls and then rises. It's falling, rising. And the fourth one is falling, falling tone. So this system is like harmony in the world. But in Vietnamese, we have lots of tones, and they are different in so many ways. And have you succeeded in watching the video about Vietnamese tones? Have you succeeded in differentiating between them? Vietnamese tones?
There are 6 of them, and they are kind of similar to Chinese tones, but there are 2 like extra tones. And yes, so there is like neutral tone, rising tone, falling tone, then the same as the third Chinese tone, like rising and falling, and the other 2, but maybe I didn't get the difference. What is these other 2 tones? Yeah.
Thank you. In Vietnamese, we do have difference between level tones and contour tones of different directions, but we also have this phonational contrast here. We have vowel duration that is also important. The red line illustrates this tone which can characterize only short vowels. So this tone is always on a short vowel, and at the same time we have a tone that is on glottalized vowels. So we have something like we can have a creaky voice here, or we can have a glottal stop here, and this glottalization is a phonational feature, but it takes part in this tonal contrast. And we can also use breathy voice and modal voice to distinguish between different tones. So we have languages, we have tonal lexical tone languages of two types: level tone languages or level tone systems and contour tone systems. Level tone systems are widespread in Africa, and languages like Hausa or Yoruba. In those languages, we have lots of syllables in a word. We have affixes, we have a complex morphology, and tones are set for each syllable of this sequence. And there are allowed combinations and restricted combinations and prohibited combinations, and tones are set according to this. And we don't have lots of tones in level tone systems. It is 2 or 3. Usually it's 2 or 3. It can be 4 or 5, but it is very rare. And in these languages, tone is grammatical. You can mark person or tense or singular or plural using tones on syllables, on affixes, and on roots. In contour tone systems, which are spread in Southeast Asia, as in Chinese or Vietnamese, we have lots of tones that use phonational contrast, that use duration of vowels to distinguish between these kinds of tones. And the difference is in the domain of this tone. In contour tone systems, tone is a vocabulary feature of words and morphemes, and very often a morpheme is a syllable. The morpheme is the same thing as a syllable is, and you just have one syllable that can take one of a large amount of tones, and it is a word itself. It is a word form itself. Tone is associated with a word or a morpheme, and it is not grammatical, as in such languages grammar works differently. So it is more lexical than grammatical, and we tend to have less. We tend to have words of less length in contour tone languages and more complicated tone systems. To put tones down, we have different systems of notation. We have IPA system that allows us to use diacritics and independent symbols as well. And we can also use numbers 1, 2, 3, 4, 5 to show the difference between extra low, low, mid, high, and extra high. And we can combine these numbers to show the path of the pitch from high to low, from mid to extra high, etc. And you can see this type of notation in many places. For example, in Pangloss collection, we have lots of tonal lexical tone languages presented in videos or audios and transcriptions. And it is typical to find their transcription like this, like a syllable and several numbers after the syllable. And these numbers show the path between different levels of in contour tones and level tones. The question is, how does stress lexical? How does word stress work in lexical tone languages? Register tone languages usually have no stress because in these languages, syllables are all equally prominent. And in contratone languages, there can be stress. There can be more tonal distinctions under stress. So it's more or less like reduction. In vowel reduction systems, we have one position that is more privileged, that allows language, that allows speakers to use more vowel qualities in this position, and in systems with differentiation of tones under stress, we also have this privileged position where you can choose between different tones for this very syllable and not for others. Now we can move to intonation, and it won't be a very long talk. Intonation can use pitch, that is fundamental frequency that we measure in hertz. It can use pauses. It can use division into parts, division this whole utterance into parts, using pitch or using pauses. And intonation also contains this prosodic stress or phrasal accent. This choosing one word out of others in an utterance. There are several transcribing systems. There is Toby and system of Janet Pierre Humbert, and you can just choose what is more convenient for you and what is traditionally set for this language. Here I have several recordings with a text that is more or less the same. It's about shopping and buying food in a store. So let's listen to different languages and look at this intonation line that shows us the changing of fundamental frequency.
Воду и мед. Привет, я купила овощи, мясо, оливковое масло, воду и мед.
It was Russian, and here is Spanish.
Compré verduras, carne, aceite de oliva, agua y miel.
We see that it is practically the same when we have different things that we put together in one sentence, as is here meat and olive oil and honey and water. Here we have this rising tone with every new thing we add to our sequence. We have this in Russian and we have this in Spanish. The same thing.
Compré verduras, carne, aceite de oliva, agua y miel.
Here we have Greek. The same thing.
Αγόρασα λαχανικά, κρέας, λάδι, νερό και μέλι.
Greek, Russian, and Spanish are related languages, and they're all European languages with no non-European, with non-strong European contacts. So the intonation is practically the same. And when we go on to Chinese, I don't know Chinese, so I can't show you the segmentation, but the intonation is as follows.
我买了蔬菜、肉、橄榄油、水和蜂蜜。
So here we have a tonal language that uses pitch that the previous three languages use as a means of intonational changing. Here in Chinese, we see that the picture is absolutely different, and with no without knowing a language, you can't just you can't see what is tone and what is intonation. So I think that it would be very interesting to read something about intonation in contour tone languages and in Chinese as well. But now I know nothing about it. I hope that our Chinese native speaker knows more about intonation in Chinese. But I think that now we can't afford discussing it more. So in this slide, we have a Greek utterance that you have already listed here. Greek.
Αγόρασα λαχανικά, κρέας, λάδι, νερό και μέλι.
And now our aim is to understand, find out what is stress in Greek. Thank you, Greek people. You put stress, put accents to every stressed vowel, so we don't need to know Greek. We just have these stressed vowels marked in the writing. So if we here we have an oscillogram, and we have intensity marked here with this line. So it's intensity and oscillogram with the segmentation into words. And here we can see that intensity is not what differentiates between stressed and unstressed syllables. For example, here we have R that is more intensive than O, which is not very surprising, as lower vowels are more intensive, are more loud than high vowels. Then we have R that are not stressed and are not pre-stressed here, and they are less intensive. Here we also have R that is very intensive, and here we have stressed R that is not so intensive. And here as well, we can see that intensity is not the thing that, just according to our eyes, intensity is not the thing that distinguishes between, is not the thing that makes one syllable prominent in a word. But duration is seems to be this thing, as we can just, if we measure the duration of vowels, we'll see that stress in Greek is durational. But even using our eyes, we can see this. That same vowels are longer under stress than without stress. What else do we have here? We have rhythm, and it's some typological parameter which deals with duration and measuring duration in sequences of sounds and sequences of syllables. I've already told you in the beginning of our talk that there are languages that in which the duration of an utterance is predictable when you know the number of syllables or the number of moras in other languages. And if you take English or Russian, it won't work neither with syllables or with moras, because in Russian and in English and in many other languages, stress influences greatly the duration of vowels and syllables. In English and in Russian, unstressed syllables are reduced and are shortened. And in English and in Russian, we can predict the duration of a sequence of words, the duration of a sentence, if we know how many stresses are there in this sequence. So this typology that differentiates between stress-timed languages, syllable-timed languages, and mono-timed languages is something that we hear, that we can perceive like some subjective feeling when we are listening to some language. We just we can feel that it is more smooth or just more harsh or something like this. It's a feeling that can be measured in terms of duration and stress and syllable and morals. We also can measure speech tempo. We can measure the number of units. We can compare tempo of different parts of this utterance, or of different syllables, or we can measure durations of different parts of the text. All of this can be very interesting when you are describing a procedure of a language. For example, you are making a language description. Go somewhere in some small language community and try to describe language and describe prosody. So very often you just have no ideas what is actually happening, and the only way is to make a recording and to measure durations and intensity, and all of this can be done in Pratt and just in your computer, which is very nice, I think. So here are some references, and now I go on to the second part of my talk, which is reading spectrograms. If you have any questions about prosody, please go on. And I'll answer questions. You can just write a letter to me if any questions appear. Do you see my new slides, reading spectrograms? Is it okay?
Yes.
Thank you. So reading the spectrum. What do we need it for? We can read language descriptions. It is not very often now, but we still, when we open some new language descriptions, we can find spectrograms there as illustrations for different phonetic processes. You can write language descriptions and use spectrograms to illustrate your point and to make your words more persuasive. You can also work with text on a language. Again, when you go to some small language community and you collect texts and you make transcriptions of these texts and annotate these texts, sometimes you just can't find out what is said, or you just don't believe your ears. And in these cases, you can use the spectrum. You can look at the sound and find out what is happening. There is some difference between what we do in this course and in real life. In real life, you usually know what to expect and what to look for, and you have, in most cases, you have a dictionary or just something like a dictionary that can help you to distinguish between words, to find what utterance is consistent to anything meaningful in this language. But here in our course, we are supposed to read the spectrum as it is, with no information about this the system. Yes, what you already know. You already know that there are different parameters of acoustic signal, of speech acoustic signal. We have intensity in decibels, which is consistent to the amplitude you see on the oscillogram on the top of this picture. We have frequency that is on the y-axis here. We see frequencies, and this frequency that we can perceive is the range of these frequencies is from 16 hertz approximately to 20,000 hertz. But the range we're interested in is frequencies up to 500 or 5,000 hertz, as most things that are most intensive, that are the most distinguishing between sounds and processes in the language. Most events that contribute to sense, to semantics, to distinguishing between segments, most such events happen in the range up to 5,000 hertz. And we also have durational measurement in milliseconds. And when we speak about spectrum, we mean by spectrum, we mean relative amplitude of frequencies. So it is important what frequencies are more intensive and less intensive in this sound. I have a question in the chat. High and low pitch differ from each other both in frequency and in intensity. High and low pitch. When we say that there is high pitch and low pitch, we mean only frequency and not all frequencies that we have here, but only fundamental frequency that is in the bottom of our picture here. So fundamental frequency is the most intensive. It is basic frequency, and other frequencies that harmonics that are present in the sound are this fundamental frequency is a frequency of our vocal fold vibrations. And where is it? Here it is. Fundamental frequency is produced by vocal folds or vocal cords, and it is a modulation of this airstream that goes normally from the lungs away, and this fundamental frequency gives us the sound that is filtered and changed and resonated by in this vocal tract. So fundamental frequency is the most intensive frequency. And for example, if you have your neighbors speaking or singing loudly or speaking loudly, you maybe you are not able to understand what words they say, but the fundamental frequency that is the most intensive can overcome these walls and come to you. So you can see you can hear intonation, or can hear their melodies of their voice. Even when you can't hear these higher frequencies that are responsible for distinguishing between different sounds. So this fundamental frequency is yes, when we say pitch, we mean differences in frequency, in fundamental frequency, not in every frequency, but in fundamental frequency. And intensity is the amplitude of these oscillations. So how high this mountain is in a oscillogram, or how dark is the spectrogram. It's intensity, so it's loudness. Intensity is how loud the sound is. Frequency is, if it is fundamental frequency, how high is the sound. And if it is about relative amplitudes of frequencies, it's the spectrum, and it's the quality of a vowel or a consonant. So it's like individual phase of a sound. It's spectrum, and duration is simple. So the first thing we analyze when we see a spectrogram is the type of oscillations. The type of oscillations depends on the source. When oscillations are created by the vocal folds, it will be voice. So oscillations are periodic oscillations. They look like something ordered and predictable, and you will see periods both on the syllagram and on the spectrogram. We also can call such oscillations just tone. How do we see that there is a period here, there is a pattern here? There is something that we see over and over again. So it's a pattern that is repeated in time. And in the syllagram, in the spectrogram, we see these vertical lines that are moments that are consistent to these peaks. Peaks are these moments of maximum of amplitude. So if you see these lines or these regular patterns, these oscillations are periodic, ordered periodic oscillations. And if there is no any pattern, like here, it's just a mess, and there is no any ordered lines or anything in the spectrogram, so it's chaos. Chaos. They are non-periodic, and periodic oscillations are called just tone, and non-periodic are called noise. What sounds contain noise? Please help me here. What sounds do contain noise?
Consonants.
Consonant sounds contain noise. Yes. And what sounds contain tone?
Vowels. Yes.
Vowels.
So, but voiced consonants, yes, they have. So the voiceless consonants are just pure noise, and voiced consonants are noise and something else. Yes. They have tone also, yes. Voice consonants a little bit. What?
Yes, that's right. Tone is a source of oscillations that is used by voiced sounds, all voiced sounds, voiced consonants, and vowels. And noise is a source of oscillations that is used in consonantal segments. Sonorants can sometimes have a little bit of noise as well, but by default, sonorants are more or less periodic. So we can say that noise is typical for not for all consonants, but for obstruents. Here we have F0, a fundamental frequency, which is produced by our vocal folds. We can have it here in the bottom of the picture in the spectrograms. And how can we find this fundamental frequency in oscillograms? How do you think? How to find fundamental frequency in the oscillogram?
It is the lowest one, and
it is the lowest one and the darkest in the spectrogram. So it is Fourier transformed sound. We also have this analysis, this differentiation between different frequencies and relative amplitude of different frequencies. But here in the oscillogram, we don't have frequencies at all. We have just amplitude in time. How can we understand if there is any fundamental frequency just using oscillograms? Do we have such an opportunity?
I think that the first indication is the periodicity itself.
Yes.
So if we can observe the cycles, that means that we have основной tone. I forgot how it's
fundamental frequency.
Yes,
fundamental frequency. Yes, that's it. If we have any periodicity, if we have this order, if we have pattern, so there is a fundamental frequency. There can be no other frequencies. There can be no formants, just fundamental frequency and noise. But if there is pattern, there is fundamental frequency. Well, let's find periods and noise. I need somebody who would analyze this spectrogram and just find and define where there is periodic something and where is noise. Who can do this for me? La, 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 la.
Yeah, sorry, Natasha, go on.
Very nice.
I'm not really insisting on answering. I just can if nobody wants.
I'll be happy if you'd help.
Okay.
Thank you.
I'm not sure I understand how to describe it adequately, because the first we can observe some sound maybe a bit before the oscillation. It's so confusing to describe it. So maybe the first is just the noise. Yeah, when you with this area, this is noise.
Okay. Noise.
And the next field, I don't know, part which is darker in the spectrogram, is, yes, it's a voice. So it's probably a vowel or something like that.
Okay, yes, we see these lines here. We
Yes.
can't see the exact pattern like here, but it's because of the scale. But we still see these lines here and here. Okay.
Yes, and then we again have a noise because it's a really chaotic oscillations.
Yes, it is.
And really dense, and we can understand what happens. And all the remaining part is a sound, probably. Maybe we can distinguish two vowels and something in between.
So all this is something periodic.
Yes.
That's right. We can see here and here we can see these lines, vertical lines, and here we can even see pattern. And we really see a difference in intensity here. We can see lots of formants here, and we can see practically nothing here, just fundamental frequency, something here, and there is something which is a little bit like noise. So it's not very very understandable. And this is this word, and sound must be available.
Foresee, foresaw.
This is the first form of this verb, so foresee.
Foresee.
And we have for here and or something like here. Then we have s that is more sharp in the beginning, and here is like just noise. And here we have this long e that changes and becomes decreases in intensity.
Foresee, foresee.
The point is we can find where noise is and periods are, but sometimes we just can't guess where is the where is this place when one vowel ends and another something begins. So here is one more slide about vowels. Here is a term formants that you already know. Formants are the most intensive parts of the spectrum. So there are lots and lots and lots of frequencies that that make this spectrum of the vowel. And some of these frequencies are more intensive, some of these frequencies are less intensive. And when there are lots of intensive frequencies in one place, they form this formant worm that we see like these black or gray, dark gray lines or worms in the spectrogram. So they are the most intensive parts of the spectrum. They're not only the only thing that this vowel has, but they are the most intensive. And we can find formants in vowels and in sonorants as well. But in sonorants, we have them more faint. And in vowels, we have every formant intensive, even if it is the third formant or the fourth formant, they all are intensive. And in sonorants, we don't have this intensive high formants, just something that is closer to the fundamental frequency. Here we have the spectrum and the syllogram of this nice word that is built up with only vowels and sonorants. and we can see this formant structure changing through the word.
waylay, waylay, waylay.
And we can see actual vowels here with lots of formants, and here as well. And as you can see, at the top of the spectrogram picture, we have something that is that remains as noise more than some periodic oscillations. The bottom of the picture is more or less clear. It is periodic. We have fundamental frequency here in gray, and then we have formants. But this the top of the picture is not very clear. It's normal. It's typical for spectrograms. Sometimes we have lots of different frequencies here, and some of them are just artifacts, and they're not important for us. Sometimes it's just background noise that is shown in this way, and sometimes it is really part of the spectrum. Here we can find vowels and silence and noise. Can somebody help me to find vowels and silence and noise? And by silence, I mean some part of the spectrum with nothing. So in spectrograms, it's white. In oscillograms, it's just a line with nothing happening here, and it's noise, and it is silence. And when we try to read the spectrum, we need to distinguish between vowels and silence and noise, and just find out what events are taking place here. Can somebody help me here? Find vowel, silence, and noise.
Maybe I can try.
Please.
Can you hear me? Okay.
Yes,
my mic is okay. I'm Aisha, by the way. It's a common misconception. Okay.
Sorry.
So no, it's okay. So I think that before the first part, before the silence is a vowel, and then there's silence, and then after silence there's this really dark, scary part that's, I think, is just noise, maybe. But okay.
Okay, go on.
So, I think, yeah, okay. I think it's noise, and then we have another vowel. Then I think, yeah, there's some sort of burst in the end. But I'm not sure. Like
yeah.
No, like in the very end, there's. Yeah.
This one.
Yeah.
Okay, it's something like a burst, and then. Well,
So
now we have just vowels and silence and noise, and so what is it?
I think it's noise.
Yes, okay. It looks like noise. It's like noise. Not very intensive. So yes, we have a vowel here. We see periodic waves here. We see patterns, something like lines, and we have formant structure here. We don't still know what formant is this or anything, but we have this formant structure. And then silence, and then noise, and then vowel, and then silence, which is a closure, and then we have a noise again. And this is the word backslide. Let's listen.
Backslide. Backslide.
So, which is nice here is that we use b to write down this word, and we don't have phonation here here during the closure, but we have phonation after the burst. That is not really the case for French or Italian or Hungarian or many other languages that are called true voicing languages or true voice languages, when in which we distinguish between voiced and voiceless sounds, voiced and voiceless stops, obstruents anyway. And here in English, that is not true voice, that is aspirating language with fortis lenis contrast instead of voiced and voiceless contrast. Here we have initial b that has no phonation, during the closure and has no phonation during burst.
Backslide.
And it is still b, and we use the symbol for voiced consonant here. Backslide. Here in this part of the spectrogram, we have three qualities, three sound qualities here. We have some sonorant, we have some diphthong here, and this form and structure is the same for all these three sounds. It changes, but it is something that is very hard to divide into parts. Vowels. As you already know, the larger is the opening, the larger is F1, and we can say that more or less F1 or the first formant is related to height, to vowel height. The more front is the tongue, the higher is F2, and we can say very roughly that F2 is consistent to backness, of vowel backness. And if we make any vowel rounded, it lowers all formants, but F2 is lowered most of all. And here we have three cardinal vowels. We have E, R, and U. And we can see that the relations between main formants, which are the first formant and the second formant, the relations, and the third formant as well, the relations between them, the place that we have between them in the spectrogram differs. In a front high vowel, that is E, we have F1 very low and then F2 very high, which makes F2 closer to F3. In R, which is low and which is a low vowel, F1 is very high, as the height is lower. F1 is very high and F2 is not very high, as it's not a very front vowel. So we have F1 and F2 close to each other. And in U, we also have F1 and F2 close to each other, but they are both lower, as the height is higher, as this vowel is higher and more back. So to distinguish between these vowels and other vowels, we just have to remember what is F1, what articulation is consistent to F1 differences and F2 differences. And we should also keep in mind these three vowels and the relationship between main formants in these three vowels. Here are more pictures. In English vowels, And we see here how we change backness of the vowel from E to U, and as vowels change to more back ones, the F2 decreases as well. And here we can also see how F1 is influenced by the height of a vowel. In E, we have F1 very low, and when our mouth is more open, the F1 rises. I have a nice video here. Maybe we'll I'll just ask you to watch it at home. And then let's go on to consonantal segments and distinguishing between consonantal segments on the spectrum. In consonants, as you already discussed in previous classes, we have different manners of articulation. We have obstruents that are stops, fricatives, and defricates. We have sonorants that are approximants, nasals, laterals, and rhotics. And we can find out what it is using information that is contained in noise and form and structure of the sound. And information about places of articulation, that is labial or alveolar or palatal or velar, etc. This information is found in form and transitions in vowels, mainly. Let's look at several types of consonantal segments and on the spectral pictures of them. Stops are made out of closure, that is silence, and burst. Aspirated stops contain this part of, or we can say that this aspiration part is a voiceless vowel, just a voiceless part of a vowel that is next to this aspirated stop. Here we have the word taken that has aspirated t in the beginning, and we have this burst here. We have a closure, but as this closure is voiceless, we can't put a beginning of this word in a rational way. So we just know that the burst is here, but when the closure starts, we just can't say. And there is a burst, and then we have some noise here, and here it is. Here we have this noise in an intensive way, like it is some sibilant fricative like s, so it's fricative noise. But then we have some part that is not at all intensive, and it is definitely not a fricative or not a sibilant fricative. It is aspiration, and it is not very intensive, and it is just not very intensive noise in low frequencies as well. And it is consistent to the spectrum of the vowel that is coming. So some authors don't have this H sound in the consonantal inventory, in English consonant inventory, as there is no such a sound as anything that we can take out of this of the sequence. That these authors think that this her sound H sound is not a consonantal segment, but is just a process, is something that happens with vowels, is as it is just a voiceless variety of vowel that is coming next. Labial stops, velar stops, and alveolar stops are different from each other in their closures and in their bursts. So in reality, we can use these features to distinguish between different places of articulation. Labial stops have long closures, as we need more time to have all these cavities filled with air from your lungs to your lips. There is more volume to fill up with air. So labial stops have long closure. Velar stops have short closures, and alveolar stops have the duration of the closure somewhere in between. The burst of velar stops is usually long and noisy, as we can't control this back of the tongue very well. So we can make one burst of, for example, of right part of this of this back of the tongue, and then left part of it, and so there can be 2 or 3 bursts of velar stops, and this is what usually happens. This is what always happens. So if you have long noisy bursts, or which is more likely 2 or 3 bursts, which are definitely bursts, so it is more likely a velar stop. Here we have the word that I will play for you.
Partake, partake, partake.
Here we see the labial one, voiceless labial one, voiceless alveolar one, and voiceless velar one. And we have a nice faint burst of a labial one here. We have a very noisy burst with a frication here. And we have several bursts, maybe 2 or maybe 2 bursts and something burst like here. And we see that alveolars in English are very often noisy and have fricative parts, along with something like aspiration here. So here we have a stop. So it's not an affricate, but noise is half of all this sound duration here. So we don't know what is the closure duration in P, but in T we see that this noisy part takes 1/2 of the sound, which is more or less the same in this velar consonant, which is normal if you have an aspirating languages an aspirating language with aspirated voiceless stops. Fricatives can be divided into 2 different types according to how they are pronounced and what characterizes their fricative noise. Fricatives, as well as affricates, can be sibilants and non-sibilants. Non-sibilants are produced with the airflow coming through the narrow channel in the vocal tract, in the oral cavity. When two articulators come close to each other, and this narrow channel is created by two articulators, for example, velum and the back of the tongue. And in sibilants, we also have this airflow that gains high speed while coming through this narrow channel. And this airflow then faces the teeth that are close to each other as well. So when we pronounce sounds like s or sh, we have our teeth close to each other, and this is another source of this fricative noise that makes the spectrum of sibilants very specific. Sibilants have this high sibilant sounds have this high frequency and high intensity noise that we can see here in our in spectrograms when it is very dark, when it is even black in the spectrogram, and when there are very intensive and noisy parts of oscillograms. There are some pictures here to compare different types of fricatives, sibilants, non-sibilants, and laryngeal fricative, so-called fricative, which we use the symbol H for. Here we have non-sibilant sounds, f and its counterpart v, th, and the. They are fricatives, non-sibilant fricatives, and we see that they are really not very intensive. So it's gray, but not very dark, and not black, just gray. And we have this noise throughout the spectrum from the bottom to the top. And here we have sibilant sounds, and they are more intensive, more dark, and even black. In s-like sounds, we have higher maximums, and in sh-like sounds, we have lower maximums. But anyway, if it is a sibilant sound, it has noise beginning from the 2000 hertz and higher. And for, th, h, and so on, all these non-sibilant sounds have noise throughout the spectrum. And here we have this h sound that looks differently depending on the vowel that is next to it. So here we have he, and we have these formant-like noisy things near first three formants of this e sound that is next to it. Here we have a sound, ha, and her sound looks differently, and here as well. So it is really like a whispery variety of next vowel, and it looks differently. It is different from these non-sibilant and sibilant sounds. Affricates have closures, that is silence, that burst, and then fricative noise. And the closure in affricates is usually shorter than that of stops, and affricates noise is shorter than that of fricatives. So we can distinguish between affricates and just a sequence of stop and fricative. And you could notice from the previous slide that in voiced and voiceless fricatives, we have the difference in intensity. Voiced obstruents are always less noisy than voiceless ones. Here we have voiceless fricatives, and in the bottom we have voiced fricatives. There is a fundamental frequency in the bottom of the picture, and we have less noise higher. Sonorants, as you already know, are very complicated. Approximants are more or less like vowels. They have faint formants from F2 and higher. Nasals have also have this faint F2, and they have additional nasal formant in 200-300 Hz. And in laterals, we often have this window, like window with complete silence, no lines, just silence, and it is typical for lateral sounds. Sometimes there is a great problem of distinguishing between different sonorant sounds, and we just can rely only on formant transitions that can help us with place of articulation. These formant transitions are have most data on the place of articulation of sounds that are before these vowels and after them. Here we have R sound between different consonants, and we can see that that formants decrease in the neighborhood of labials, and they can some F2 can increase if there is a velar consonant nearby, and R and F2 in R does not change significantly if there is an alveolar consonant nearby. So different vowels react differently to different consonants that appear to the left and to the right of them, and we should keep that in mind when we read the spectrum. Well, when we just have a spectrogram and we need to find out what the word is, firstly we find vowels and guess about syllables, maybe not. Then we find acoustic events or changes. We find silence and burst and fricative noise. We can find formants combined with fricative noise, so acoustic events. And then we go from the beginning, rightwards, or we can start with the segments we are sure of and use this information about acoustic events. And then we can guess what are these segments. And there can be variants of these segments, and that's okay. And then if we already know the language or have a dictionary, we can find the combination of these segments that makes sense. And there are some variants of some pictures with infinitive and past simple forms of irregular English verbs. And when the slides are available on our website, I just ask you to look at these pictures, and the keys are presented here, and just try to go through the algorithm of reading the spectrum and come to the real forms that are here. Or, for example, here we have two verbs and two words and two pictures try to understand what picture is what verb form, and try to find out what is the difference between them. Here on this slide, I have 6 very nice links, and these are videos with very, very nice explanations of reading the spectrum and with reading practice. Very, very short videos and made very well. So please follow the links. It's just 4 minutes here and 4 minutes there, and another 10 minutes here, and it's perfect. You will improve your reading skills a lot. So this is all that I wanted to tell you. And if you have some questions, please don't hesitate to ask. What will we hear if we delete F2 and F3 in Pratt for E, for example, or F1 and F2? Will we hear the same E or some other sound? Or if we combine F1 of E and F2 of O? I don't know, but we can try. We can try and find out. Garik, what do you think?
No, this is actually hard to do in Pratt, because in what I showed you, that it's possible to actually to remove time periods or copy and paste them. So it's hard to, for instance, do the same thing in frequencies. I guess.
I think
but
that we can
you
remove.
definitely can do this because. Sorry.
I think we can remove frequencies. Can Pratt make a filter for some frequencies?
Maybe I'm not sure, but the idea that you can do this via filtering, so
I think that
add some filter and then.
I think we did this to sibilants or to something. We just we together just cut off the frequencies that are higher than something, and we cut off frequencies higher than 2000 hertz, and we could not distinguish between different sibilants. I think that, so if you could cut some high frequencies, maybe you just can cut off some part of frequencies.
Yeah, but I don't know how to do it in production, but yeah, we definitely
Okay,
do.
we can just think it over. It's more interesting in vowels. I like this. I like this challenge of deleting F2 and F3 for E. If we delete F2 and F1 and F2, there will be no chance to distinguish between vowels, because F1 and F2 are the most intensive of these meaningful formants. So F3 is not, I think it's not possible to distinguish between different vowels having only F3. At least because it is not so intensive, and so not so prominent. So F1 and are there any more questions for us? Any more questions?
I want to ask, so the intensive is related to the airflow?
F0, yes, fundamental frequency is the most intensive of all frequencies of the sound.
So the full have a more intensive than the V. right?
Yes, it has. It is more intensive. It is more intensive in tone, but noise can be also very intensive, and so and that's why when we have sibilants, voiced and voiceless, the noise can be so intensive, so it is more loud than fundamental frequency that is consistent. Because when we have voiceless sounds, we have this airstream free going out in a free way. So the vocal folds are not vibrating. Their glottis is open. So the more the wider is this glottis, the more air can go out. So the louder is the sound. So when we have vocal folds vibrating, we have less air going out, and that's why this sound can be not so loud if it is if it's an obstruent. And when we have a vowel, voiced and voiceless, of course, the voiced vowel will be louder, will be more intensive. So it all depends on noise as well, not only just fundamental frequency.
Thank you.
Questions? 1, 2, 3. I think there are no questions, and if there are any, please text me or write me a letter and ask. I think we can finish here. Garik.
Yeah, probably. I can't see actually filtering option in Pratt, but it could be done.
You can use any other something like Audacity.
Yeah, maybe. I need to figure out how to
Something
do
like
it. But it should be. So what was the question? The idea that we removing formant frequencies at all, and then we can distinguish formants? That was the question.
It is in the chat.
Okay. Sorry.
You see?
Yeah.
So I think that we should just copy these questions somewhere and think it over.
Yeah, maybe I can't do this right at the moment, but this is the question. I think that at the next time I will prepare. I will do some prep for exactly answering this question.
Thank you so much. I think classes are over. Yes.
Okay.
Any announcements? No.
Yeah. Okay. Let's go today. So thank you, Ina, for having the class. Thank you all for coming.
Thank you. Goodbye.
Thank you.
Thank you.
Thank you.